All right, hello to everyone. This is your 7.5 Part 1 notes. We'll be talking about exponential growth functions. It's probably the first time we've talked about this semester, but we're going to be graphing exponential functions. And if you read the definition here, it says an exponential function is a function of the form y equals a times b to the x power, okay, where a can equal 0. B has to be greater than 0, and B cannot be equal to 1. Notice that the base is a constant, so B in this y equals A times B to the x. Okay, notice that the base B is a constant, so it's just a number. It's a constant that is greater than 0 and not equal to 1. And the exponent is our variable. So the exponent, again, the x here is the variable in this function. Exponential functions are nonlinear, so these will be one of the nonlinear functions we talk about. Here our key concept box, as I scroll here. An exponential function is a function that can be described by an equation of the form y equals abx. Again, a is not 0, b is greater than 0, and b is not equal to 1. And you just have some examples of how we write exponential functions here. Y equals 2 times 3 to the power of x. Okay, so in this first example, 2 is a constant. 3 also our base. Our base here, our b value is 3. A value is 2. And again, our exponent is a variable x. So that's where we're going to be substituting values into this function. If you guys remember with linear function, we would plug in x values and find out what the output, what the range value, the y value was. And we'll be doing similar work here today where we're plugging in values for x. So our exponent is going to change. It's a variable, right? And this y equals 4 to the power of x. Here, a would be 1. We don't see the 1 there. That's because we don't write 1 times something. That's kind of common for us. And then here our base, our b value would be 4, and again our exponent is the variable. We won't talk about this next type of function today. We'll talk about that tomorrow in class. But notice what's different about this one. Again, a here is 1. The base is a fraction. Okay, we haven't seen those. We haven't worked with a base of a fraction in any of chapter 7 yet. So that'll be something we explore tomorrow, and then we take a look what those graphs might look like, and well, how do we even evaluate when we have a base as a fraction? And we use our properties of exponents to explore that again tomorrow. So let me take you through 3 examples here. Be similar to the 3 problems you'll have here on your homework. So the first function we're going to graph here is y equals 2 to the power of x. Here our a value is 1. Base, our b value is 2, and our variable is the exponent. So substituting values for x. So very similar to when we do linear functions. I'm sure you guys have seen these before. I'm going to make a t-chart over here. And this is going to tell me what values. It's actually not these. The values of x I'm going to plug in. Okay, and for all of these functions, the values of x that we're going to plug in are going to be -2, -1, 0, 1, 2. By plugging in those values, we'll get a good idea of what this exponential function looks like. And then we're gonna find out what is the output, what is the y value when we plug in -2. So again, what are we plugging this into? Y equals 2 power of x. So these x values are going to be -2, -1, 0, 1, and 2. So when we plug in, this can be a lot of calculator work, guys. You're welcome to use your calculator on these because we're gonna end up with some fractions and things of that nature that I know we're more comfortable with on our calculators. So I'm going to show you how we do it using properties of exponents because that's what we've been working on this whole chapter. But I'll also give you guys what you should see on your calculator as well. So All right, let's get started. First x value we want to plug in, -2. So y equals 2. Where we're plugging that in at is for our variable x, so 2 to the power of -2. Well, again, we've worked on this all semester really to this point. With negative exponents, guys, if I want to find out what y value this is going to be, I'm going to use my properties of exponents, okay? Negative exponent, I move my base of 2 to the denominator. So this would become 1 over 2 squared. 2 squared is 4, so the y value here is 1/4. All right. So that allows me then to plug in, or not to plug in, excuse me, to plot the point, the ordered pair, -2, 1/4. All right, and so we'll come over to our graph here and we'll plot that point. -2 up to 1/4. Well, 1/4 is going to be just above our x-axis there. So that's about where that point would be. If you're looking here at the graph, it would be at the x value is -2, the y value is 1/4. So that's about as accurately as we can plot that. If you guys were to plug this into your calculator, you didn't want to long end do the properties of exponents, what would that look like? So if I'm plugging in 2 to the -2nd power, I'm going to do that down here. Calculator. Right. So you'd put your parentheses around your base, like we have been. You'd use the caret button. When we're plugging in a negative exponent, we actually need to use parentheses around the exponent as well. So this is what it should look like on your calculator, and then, of course, when you hit the enter button, the calculator is not going to give you the fraction 1/4, it's going to give you the decimal 0.25. So you might check that on your calculator. Nonetheless, that's still plots where we plotted it. Okay, so if you're using your calculator, this is how you'd be plugging that in. Of course, these values 2 and -2, it's going to be dependent on the function we're using. All right, so let's get to our next x value of -1. So 2 to the -1st power. Well, that would be, again, property of exponent. 1 over 2. When I move that 2 to the denominator, my exponent becomes positive, so this is 1 over 2 to the 1st power, which is, of course, just 1/2. So when I plug in -1, I got 1/2. So that is my ordered pair. Come over here to -1 on my graph for the x value. I'm going to put about 1/2. So 1/2 will just be slightly above my quarter point. So, and if you were using your calculator on this one, you would use your parentheses around your base, caret, negative exponent, we need to use parentheses for that, -1, and we get 0.5 on the calculator, which is 1/2. All right, favorite x value to plug in? 0, of course. Well, why is that? Because then my exponent is 0. Anything to the 0 power is 1. All right, so when I plug in 0, I get 1. So 0, 1. Plot that on your graph there. It's on my y-axis, 0, 1. And then we've done that one. Of course, plugging in +1. Well, 2 to the 1st power. That's just 2. So we got plug in 1 for x. We got 2 for y. So we can plot that over pair 1, 2. And then let's plug in our last x value of +2. And so we'll just do that in again for the exponent. 2 squared, guys, of course, is 4. And so we plug into 4. So we have 2, 4, and we plot that point. So this graph, after we've plotted these 5 points, well, we're just going to kind of connect the dots. All right, these can be a little tricky to graph, but we want to just start, connect, and make sure, okay, as we keep going, we show that function is going to increase. And I know we talked about at the beginning of the chapter, exponential growth increases rapidly. That's why I drew such a steep curve. And if we continued plugging in further x values, we would see this this curve, this growth happens very rapidly when we move up quickly like that. All right, and then as we go the other direction, if we were to plug in negative values, guys, this would actually just continue. I just drew it where I didn't want to. This can be tricky drawing this left part of the graph, because what this does is it is always going to approach the x-axis, but it will never actually cross it. So it really kind of flattens out almost as it moves towards the negative values. So that's what an exponential function is going to look like. We'll see these next few examples. While the function might look a little different, we might have different a values. I think the base is still going to remain 2, but we'll see that they do look similar. Okay. So, all right, so different a value here. So here, the a value of this function is 1/2. The base, again, like I said, base is still 2 here. All right, we're going to same exact idea here. We're going to make our chart of points. I'm going to give us a little more room here. You might want to do the same. Plugging these ones in. A little more work. So give yourself a little more room there. And let's do that. So again, the x values we want to plug in, those aren't changing. That's going to be -2, -1, 0, 1, and 2. All right. We're plugging them into our function. 1/2 to the power of x. So again, the exponent is a variable, so we're substituting our x values in. All right, so let's get busy to plugging in. So y equals 1/2 times 2, the x value is -2. Again, negative exponents. Well, what does that do to this 2? That means this base 2 needs to move to the denominator. So this would be 1/2 times, when I simplify this 2 to the -2nd, that becomes 1/2 squared. All right, so this becomes 1/2 times 1/4, 2 squared being 4. On your calculator, 1/2 times 1 divided by 4. Okay, that's going to give you, and I'm going to encourage you guys to make sure you're using these calculators, guys. 1/2 times 1/4 is equal to 1/8, which is 0.125. Okay. And so when I plugged in -2, the output, the y value, was 0.125. So when we come over to graph that, again, I go back to -2 on my x-axis, I'm going up 0.125 on my y value. So that point's going to be just about as close as we can plot it to the x-axis. All right. Continue plugging in points here. 1/2 times 2. This time I'm substituting in -1. Oh, what's that look like? That looks like 1/2 times. Let's simplify that negative exponent. So I move the base 2 to the denominator. The exponent then becomes positive. So this is 1/2 times 1/2, which is 1/4, or 0.25. So my ordered pair, -1, 0.25. Over to our graph, we go out to -1 on the x-axis, up 0.25 on our y. So again, these points, we can see this growth isn't happening very quickly over here in the negative values, but as we move into our positives, we're going to see this thing grow pretty quickly here again. Substitute in our 0 exponent. Again, 0 is my favorite value here to plug in, because anything to the 0 power is 1. So this would just be 1/2 times 1. Of course, 1/2 or 0.5. So 0, 0.5. And I come over here and plot that as best I can on my graph again. All right. So our y values, they haven't even gone over 1 yet. We should see that change as we plug in 1 here. So 0, now putting in 1, so 1/2 times 2 to the first power. 1/2 times 2, guys, versus 1. So we have the point 1, 1 on this graph. There we get to the value 1. Now we're plugging in, I'm not sure. Now we're going to plug in 2. So this would be 1/2 times 2 to the power of 2. 2 squared is 4. 1/2 times 4 is 2. So I plug in the point 2 and my output is 2. 2 is a point. And again, we're just connecting the dots over here in the negatives. We're just trying to keep it as close to the x-axis as possible. And we're showing that it's going to grow quickly as we continue in a positive direction. All right. Again, guys, use your calculators if you need to. I've shown you guys how the properties of exponents apply here. Really, this next one, I'd like you guys to go ahead and pause and actually try this one here. All right, so what's that going to look like again? Give yourself plenty of room here. Here, my A value is -5. So that's going to be a little different. It's going to give us some negative values. The base, again, still 2. Right, the base can change, guys. I use 2 just as a common base here, so that that part wouldn't maybe confuse us as much. So still plugging in -2, -1, 0, 1, and 2. Notice as these grow in complexity, I am leaving ourselves some more room over here. So let's get to plugging the points in. So I equals -5 times 2. I'm substituting in a negative exponent. Simplifying this, as you could plug all that in your calculator. This would become negative exponent, that becomes 1/2 squared. All right, so this is -5. 1/2 squared is 1/4. So this would be -5 times 1/4, which is -5/4. Or, if you're using your calculators, you would get -1.25. Either 5/4 or -1.25 is a decimal. So the ordered pair there is -2, -1.25. All right. Come over and plot that. So -1.25. Let's see, about right there. That ordered pair will be. You guys go ahead, plug in -1, 0, 1, and 2. Give those ones a shot here on there. So go ahead and pause and do that. All right. So if you're back with me here, -5 first, -5 times 1/2, -5/2, or in your calculator. Well, let's stick with the same format here. On your calculator, that'd be -2.5. So 1, so -2.5. So we do our best to graph that one. Put it about right there. This one's looking a little different. That was some quick growth, so I wonder how this is going to look as we keep working here. -5 times 2 to the power of 0. That's just -5 times 1. And the power of 2. So the result here is -5. I plug in 0, I got -5. Over here and plot that. Let's continue to plug in 1, -5 times 2 to the first. Hopefully the first is just 2, so this is -5 times 2, -10. So 1, -10 is a point that we can use on our graph. So yes, we're seeing that growth is happening rapidly. I wonder, it seems to be happening a little more rapidly. That is because of our A value. Okay, it's that constant out in front there. So then as we plug in negative, or positive 2, excuse me, -5 times 2 squared. 2 squared is 4, so -5 times 4 is -1. So 2 -20 is on our graph, and that's where the graph actually stops there. So we're connecting our points. This one all is occurring below the x-axis. All of these y values were negative, and so that's also because of our a being -5. All right, that's where we're going to stop today. The substitute should have a homework assignment for you, so you at this point can go grab that from her and get busy. There should be 3 graphs there, pretty similar. Everybody have a great afternoon, and I'll see you all tomorrow.